So yeah, I got my iPad right here with me right now, and so we can get started and talk about my project a little. So here I have a multi-class food classification problem. I know that's a mouthful. Basically, we're classifying food. It's as simple as that. And using computer vision, of course. Now, like every project, I like to start with why. Why did I choose this data set? And in this particular case, ever since college, I've been obsessed with food, and in particular, after I started volunteering at a local farm in college, I got all into food and food startups and things of that nature. And so whether it's, trying to use data to help ghost kitchens in their business decisions, or if it's, using an image classifier to classify food on plates like this particular project, nothing gets me going like these projects. And ever since I've pivoted into data science, actually, I really enjoy looking for some problems that involve food. So let's get started. The data was from a Kaggle set. Now, it's not from Kaggle, it's just someone posted it on Kaggle. It's actually from a Japanese university, and I found it that very, very interesting. And it has around 101 different categories of food, and it has around 1,000 images for each one. So that's totaling around 101,000. And so the first thing I had to do with that data was explore it and process it. Now, I don't want to go into too much detail because this is going to be a short video. I'm going to do a longer video later on so you can see that. But you just need to know that I had to process the images, and I had to, work with the data in the beginning. Just do a little bit of data munging. Now, one thing that's important to note in this step is that I definitely had a holdout set and a validation set. So I did a 70, 15, 15 split. So 70% went to the training set, and 15% went in validation, and 15 went to the holdout / test set. I also randomly chose, using np.randomChoice, some 5 from the dataset, so just 5 classes, in order to test on my local machine to make sure my models were good before I moved them on to AWS instance and left them running overnight. And I'll talk more about that later. So the randomly chosen ones were apple pie, waffles, gnocchi, chocolate mousse, and baklava. So here you can see some pictures. These are like 100 of them, and there's 101, so there's only one missing in this picture. But if we close up to only 20, you can see that all of the images are squares, which is actually really helpful, but they're not all the same size or resolution. And the plates are different, the locations are different, everything. Some even breakfast burrito, if you see, has 2 plates in the picture, although one is more focused than the other. So I had to deal with that, doing some data augmentation to kind of make it so that the model would see a lot of different images, see a lot of different versions of this image. So one of the things I did was grayscaling. I also rotated 90 degrees, and I did a bunch of other stuff. And you can see actually right here, in the end, my models performed best with a shear range, a zoom, and a horizontal flip. And you can see that these waffles have been processed. So this is what the machine was seeing. Yeah, they look really cool. Then I have some code examples, but again, this is a short video, so I'm skipping over those. If you really want to dig in depth, like I know you probably do, just go to my GitHub and you can find it. So now let's just start classifying using a simple model. So I used convolutional neural networks here, so CNNs, and the first one I did is I called it the tensor model. And this is mainly because I got it from a TensorFlow documentation. It's a very simple cookie cutter example, but I wanted this to be my main model. Sorry, not my main model, my basic model to compare everything to. And so the model had around 8 million parameters, and I ran it, basic stuff, really. And after running it for like 20 epochs, you can see right here that I was pretty good at guessing. It got 50% right, which is really cool for the 5 classes. And it did that super quickly, like maybe 20 minutes. But you can see here that I was definitely overtraining. The blue lines go up really fast and then go really low with training loss. But you can see that the training and validation accuracy, they separate. And that's not what you want usually on your model. So I was overfitting. So the thing I thought of first was, hey, let's add some dropout rates, because dropouts, they prevent the model from overfitting by kind of forgetting some data. That's kind of what they do. They turn off some neurons, which is really cool. One thing to note here is that guessing for 5 classes would be 50%. So getting 50 means that the model is learning, in fact, which is cool. Let's skip some of this stuff. If you want to look at it, it is on my GitHub, but after adding the dropout rate, I basically got to something like 56%, which is great for a basic model, cookie cutter model that I didn't do any work. So then I created my own custom model, and it had around 17 million parameters, so almost double, actually more than double the parameters. And yeah, so here I had set the dropout rates to 0.5. I used the loss categorical entropy and categorical cross entropy, and I used the optimizer atom. And this is kind of a good example. You see this picture right here is a really good example of what it looks like. And then yeah, so I only got around 0.2, which was not good. It's like guessing, so the model wasn't doing that great after running it for around an hour. So then I decided to change the kernel size, and here you can see on my screen what the kernel size really is. It's kind of like a filter that goes over, and I made that smaller, and it worked really well. It went from 0.21 to 0.28 training accuracy. Oh, sorry, validation accuracy. And then I lowered the dropout rate because I wasn't overtraining, and I reduced pool size, and I changed the dense neurons, and in the end it looked like 33 million parameters, and you can see in the graph it just didn't work out. It wasn't that great of a model, and I got something around 47% accuracy, which is worse than my cookie cutter model, so not good. So I'm gonna move on, and now that I have like a really basic model, I'm gonna move on to AWS. And an AWS instance basically allows me to move off my local machine and SSH into some power, which is what I wanted to do. And since I had a lot of power, we can go all the way down to transfer learning, some deep learning techniques. So here's just kind of, some quick things I did to get my AWS set up. I put my images there, I put my GitHub there, and I went to use a model developed in 2014 for image classification, and it won an award, and it's called the VGG16 model. And I went with this one. As you can see in my graph how it looks like, it looked really promising for my data set, and I had to do image processing and whatever beforehand, but I'm skipping that right now. And I had to turn off the head of this model in order to use it, and then I trained my own head, and then after that I actually unfroze around half of the parameters and tested it with that. And I'm just going to tell you guys, it didn't do that well. In fact, guessing for, again, I used 101 classes now that I had the power to. Guessing is 1%, and I was doing around 1% or 1.2%. So it's bad. I was doing really bad. So I was like, okay, not good. I'm going to move on to something else. And so I did. I'm going to skip through the image augmentation, like I said, because it's mainly the same as before. And yeah, I had like 12 million parameters, but it didn't end up working well. So I then decided, hey, how did our basic model do? How would the TensorFlow model do if I was putting 101 classes through it? And in fact, it did really, really well. I got 26% accuracy in our test, which is amazing. And in fact, here I actually put on my screen the top 1 accuracy, which is that it guessed right the first time, was 26%, like I said, but the top 5 accuracy was actually 55%, which is that's amazing. That's really, really good for such a simple model that you can just put into your data set and just, kind of cookie cutter. Amazing. But I wasn't that happy. I wanted to know more. I printed out this heat map here that's really small, so you can't really read it, but I used this to know where I was really failing at, and the model was really bad at things like hummus and omelets. Alright, so then I decided to use something else called the exception model, and let's just say that this model did exceptional. It did really good. The setup, again, it was very similar to the previous example because it is a transfer learning technique. I had to freeze everything. I had to make sure my images were the right sizes. I had to set up a learning rate to prevent the model from kind of quickly unlearning what it had learned before, since this is a pre-trained model. And so I had a learning rate of 0.2 with some decay, and I use stochastic gradient descent, and I froze everything but the head, and I had only 200,000 trainable parameters. But then, actually, wait, but before I move on to unfreezing the whole thing, just training the head with this model, I got a 56% accuracy rate. Wow. That is, for 101 classes, that's impressive. That means that I'm classifying 50,000 right and 50,000 wrong, which is incredible. Like, I definitely taught the computer to see. Now, the top 5 accuracy was actually even higher at 82, which is like amazing. Now, what happens if I unfreeze the whole thing? I'm very optimistic for this model, the exception model. So, like I said, I unfroze everything. I set a learning rate to prevent it from unlearning, but lower this time. Although, my learning rates were always high because I was trying to go quickly, and I trained it for 4 hours, just like the other exception model where everything was frozen. That was also 4 hours, so a total of 8 hours. And I got the model to predict top 1 accuracy of 79%, almost 80%. That was like the top 5 of before. And the top 5 accuracy of this one is 93%, which was kind of crazy. And you can see from this graph, I was definitely overtraining this model as well. Sorry, overfitting this model as well. And you can just see by the difference between the blue and the orange line here. So I definitely wanted to add a dropout rate probably in between the dense neurons in the end. Kind of at the head level, I probably add a dropout rate there. So that was my next step. But are we improving? Yeah, we are. We moved from the tensor model, which a cookie cutter example. We had 26% accuracy, and then we moved to the exception model, training for 8 hours and getting an 80% accuracy, almost 79%, which is amazing. So let's predict now using the exception model. So I put this image that I got from online into the model, and it thought it belonged to cupcakes. And you can see that this is a picture of sushi, so it looks very similar to cupcakes. It's like in a row of 6. It has something on top. It's white in the bottom, like a cake would be, understandable. But it also wasn't sure about this one. So probably in the top 5, it had predicted sushi. Next, I added some hummus. And hummus, like I mentioned before, was doing the worst in the model. And in this one, it got a 96% accuracy, confidence that it was hummus, which is correct, which is awesome. So some final thoughts here. I wrote like this whole blog basically about like what my final thoughts were, but it's just important to know that this was a very difficult problem, and my custom model did very poorly, but these pre-trained models did very well. So always use pre-trained models if possible. And some next steps would be trying to unfreeze the exception model slower, kind of doing the whole process of transfer learning, see how high we can make that accuracy. I'm sure we can get it into the 90s. And some potential use cases for this, like I mentioned earlier, would be something like food quality control, or even like part of a restaurant application like Yelp. I'm thinking that users can post their food, and if a menu from a restaurant doesn't have that food image, then once the user posts the food, it can automatically be classified and put next to the menu item so people could understand what that food looks like in real life. And that would be really cool for me, I think, and to see when I choose restaurants, to know how the food really looks like. And yeah, so that was just one potential use case, and that was my entire project. This project took me only a week, but I'm sure that with 2 weeks you can make it very, very nice. And you can maybe even try another deep learning technique. So yeah, that was kind of it for this video. I'm gonna probably do a more in-depth video, maybe even one where I show my code for this in a Jupyter notebook, and maybe even a video where I talk about how to set up your AWS to learn to train models overnight. So thanks for watching, and I'll see you next time.